Hi folks, welcome to The Break Key. My name's Henry, and today we are going to get some text entry working on this custom ROM. So I would like to say that we're going to get as far as doing the actual arithmetic, but I've been playing with this off to the side, and it's surprising just how much work and effort goes into simply getting text to appear on the screen and how to get to interact with it sanely. So it's a little bit of a departure. There may be some mistakes that you get to follow me along with. However, let's go ahead and take a gander at this. It really is surprising just how much goes into simply making text editable. And today we're going to make text a little bit editable right here on the Break Key. So as we're doing this, obviously we still want to go ahead and make sure that everything's cleared out. There's going to be some information that we're going to need. We're actually going to need to hold on to the key presses. So before we even start, we're going to set up some variable areas. So we're going to, the key press buffer is going to start at hex 0200. Now the number of key presses we have is going to be 8 bytes. Now there's only 7 bits that we're grabbing, but it's going to be 8 bytes. Remember that Remember that the keyboard matrix is polled on the columns, so each column is sent the signal, and we have 1, 2, 3, 4, 5, 6, 7, 8 columns. So we're going to need 8 bytes, even though we're only looking at a 7-bit byte. 1, 2, 3, 4, 5, 6, 7. All right, so we need 8 bytes, which means that whatever our next variable is going to need to be 8 bytes later. So this is going to be an indicator for our start of line. And then our current cursor location will hold at 210. Is that correct? No, that's not right. I wasn't thinking in hex. I was thinking in, I apologize for that. That's 020A. Okay, we'll hold at 020A. That's going to be the current cursor location, or where the next character is going to go. Not where the next where the current character is, but where the next character is going to go. The next thing that we're going to need is to know whether or not the shift key is pressed. Now, what I've decided to do is look at the releases as being when the key press is complete and when to put the character on the screen. And so the shift key, however, we need to know when it's pressed, and we need to know the entire time it's pressed, because that combines with, so that's a modifier key for all the other keys that are on the keyboard. Well, most all the other keys on the keyboard. And we're going to go with the idea that the shift key being down is indicated by a non-zero number. The shift key being down, or the shift key being up, is indicated by a 0. Okay, so now you'll also note that I haven't actually allocated any space here. That's because these equates are simply going to be placeholders to let us know where things are. Let's go ahead and get those cleared out. Oh, let's fix this while we're at it. This was something that was pointed out to me a couple of episodes ago, that I was loading from the memory location rather than loading an immediate. All right, so that fixes that. All right. So we've got that. Oh, you know what I forgot to do? I forgot to give it a place to go back to. All right, so there we go. That takes care of that. And we clear out the PIA controls, set the PIO directions. That's all part of the bring up process. This works. So here we're going to have to make a pretty sizable change. The entire method of polling the keyboard, we're going to switch up a bit. Now, over here, what we'll note is that the shift key is on column 7, 0 through 7. This is on column 7. So the first thing we want to grab, as far as what we have, the first thing we want to know is the shift key pressed? Now, all of this right here is going to be stuff that we use for our visualization, so I'm going to just go ahead and clear this out. With that, what we're going to need to do is change over completely the order that we were looking at things. We would start in column 0, and we would go from there, moving left to get to the next column until we were done with all the columns. Here we want to reverse that. We want to start in column 7 and rotate right. So instead of starting that with an FE, what we're going to need to do is we're going to need to start that with a 7F. So now, again, just like we did before, we're going to need to set the carry flag because we're going to rotate through the carry flag in order to determine where we're at. Now, everything that we do as far as figuring out what's going on, we're going to throw into the key press buffer. And we're going to be referencing the key press buffer. And I will show you why. So the big trick here is let's say we've got a keyboard pole with the values. Okay, let's say we've got one with those values. With those values right there, those coming out. And remember, we're talking reverse sense here. All right. What I've got there is I've got row 2 and row 6 are pressed, and row 7 is, the rest of them are not. That's great. They're pressed. That's not a problem. But what I need to know is when have they been released? So now I get a new I get a new column in, same row or same column. I get a new column in for this column, and it goes 1 1 0 0 1 1 1 1 0 1 1. Okay, great. So that gives me, if I take these and exclusive OR them, what I wind up with here is a 0 1 0 0 0 0 0. Okay, great. Now, that's great. Has it been released? Lovely. But what if I take the same one and that's released, but now the next one is pressed? Now when I do the EOR, I get this value right here. And so that's a bit problematic in that now I can't tell the difference between a press and a release. Is there something we can do to figure out the difference between a press and a release? And the quick answer to that is yes, there is. So if I take this and I AND it with the current press information, what I get is 0 1 0 0 0 0 0. I get the releases right there. That's what I get, is the releases. So I have to hold on to the last set of key presses, not update until I process the current key press set. I'm using the prior key press set to determine where the deltas are, where the changes are, which is something that exclusive OR is exceptionally good at. It'll show you the deltas. But the deltas alone aren't enough. I need to figure out what actually changed, and the current key press state. That current key press state gives me that information by ANDing it out. So here we're worried about key releases, not key down events. So we're looking at the key up events. I want, is it pressed and has it been released? Those two. So I'll go ahead and close that. No, I do not want to change that. And I want to come back to where I was before. There we go. And you can come right back over here because I was using you. All right. So with that said, the first thing that I'm going to do is I'm going to make sure that I've got the key press buffer available to reference. The other thing is that I'm going to wind up putting things onto the screen, so I need to know where the cursor currently is. So now comes the fun part. Actually grabbing the data. So we're going to want to save that for later. Let's see, did we do that last time? We did not do that last time. Yeah, we're going to need to save that for later because we're going to be playing with this a bit to make sure that we know what's going on. So we don't need to check the shift key unless we're actually in row 7. Or in column 7, I'm sorry. Now, this is an important little thing to note, the bit instruction. The bit instruction performs a logical AND. So, if we have bit 8 set, or bit 7 set, if we have bit 7 set, then what's going to happen is we're going to wind up with this giving us a not equal. Bit 7 set, if you remember this is all reverse set, bit 7 set means that we are not in the 7th column. We're in another column. Bit 7 clear would mean we are in the 7th column. So with bit 7 set, we would have a not equal condition because it would not be a 0. And again, here with the shift key, remember this is on 0, 1, 2, 3, 4, 5, 6. This is on bit 6. And bit 6 has a value of hex 40 when you put it into the binary condition. So now we're testing that bit. Again, remember this is all reverse sense, so if this is pressed, this is going to be a 0, and we're going to be in a non-zero condition if that bit is not pressed, if that shift key is not pressed. I think I'm going to do something here before I forget to do it, and it drives me crazy. I'm going to get rid of the initialization. Did I put the initialization up here? Of the is shift. I'm going to get rid of that because I'm going to go ahead and clear that flag at the beginning of the keyboard poll. So, and that's done at the beginning of the poll, so that way if we hit here, we only have to worry about complementing it. We don't have to worry about clearing it later. We'll happen to back up at the beginning of the loop. We're only going to hit the shift key once per loop because once per main loop, because we're only polling the keyboard once per main loop. Okay, great. So now we've got our shift flag set up. All right. So at this point, we're done with all our shift processing, so we need to put that marker in place. And we're going to go ahead and calculate our key deltas like I was saying before. Remember what we saved the initial value of B on the stack. The first thing I want to do is check and see if we even have anything to process. So we'll look at now the branch equals. Again, if this comes up with a 0, that means nothing there is set. Remember that we now have the presses, which are positive sense, and the releases, which are positive sense. And so any releases we need to process. With a 0 in there, no, there's nothing we have to process. This is just to make my brain work a little bit better. So we're going to invert A, and we're going to work on that in a positive sense. So columns 0, 1, and 2 have a few important keys that we might need, that we're going to want to capture. We've got the enter, we've got the clear, and we've got the break. Okay. So enter is going to move us to a new line. Clear is going to clear the screen, and break, well, it's not going to do anything just yet. We'll worry about that later. but we do want to get those special keys captured and out of the way. Okay, if we're in those columns, again, if we have something set in column in row 6, or I'm sorry, yeah, in row 6, then we've got the enter, clear, or break. Those are on the 6th row. And we'll worry about processing those later. Now that we're at the end of this, let's go ahead and make sure that we're not looking at anything other than the characters, which is going to be, or anything other than the printables, which is going to be 0 through, 1, 2, 3, 4, 5. That's 0 through 5, which if I mask those off, that's going to be a 3F. And I'm masking instead of bitting because I'm going to process those later if they exist. Now we know we have at least one character to process. What I'm doing is I'm calculating the column number. So the problem that we have is, if we look at this, everything is pulled by columns, but everything adds 1 based on what column it's in. So if I just go with the numbers on the row, everything gets jacked up. But here what I can do is actually look at the column numbers and add those into the row number that I'm in. If I take the row number and multiply that number by 8, now I've got a number that I can work with. So let's go ahead and get that done. All right, so clear Y. Y is the cursor location, so we need to clear that out. And what we're going to do here is we're going to do a simple binary search. Okay, we'll break it down. This will only take like 3 iterations rather than going through a loop or anything like that. The first bit here is, okay, which nibble is hot? Okay, where do we need to put this thing? And here's a key part that we're looking at. We're calculating this out, so every time we go through one of these, whether the bit exists or not, we need to shift. We need to shift it to the left 1 bit for each one we're running through. All right, so next we want to look at whether or not, Control Z that, there we go, whether or not we have the second bit in our count number. And now we look at our final one. Okay, so that takes care of that. So now at the current location of the cursor, we have a value which contains the column number, which is a number between 0 and 7. So this will be added to the value that we determine from the row number. We're going to work from the least significant bit to the most significant bit. And all we have to do in order to do that is push off the least significant bit from the right side. And that least significant bit will, as we know, wind up in the carry flag. We can work with it from there. That's a pretty easy way to do it. And it also goes ahead and gets us ready for our next loop. So let's see. We're looking at the row. So first thing we do is we do our left shift. Oh, no. Did I say left shift? I should have said right shift. Yes, right shift. The right one is the least significant. So we're going to right shift that off, and that bit goes into the carry flag, and then we've got all the rest we can deal with. So we go from our least significant to our most significant by shifting off to the right. Okay, LSRB. And remember that what we're dealing with here is positive sense, because we've already manipulated this so that our releases are positive sense. So a 0 in the carry register means that we had a 0 in the bit, means that we don't have anything for this row. Now, this is the key for the first bit of the group. If we've got something in the carry clear, then we already have the value. The 0th bit there doesn't do anything other than, or the first bit as I called it here, let me go ahead and make that a little bit more clear. Okay, the 0th bit has a 0 value. So we've already got the column number is our actual value. Let me look at it. Let me point it out over here. So this is right here. This is the 0th bit of the row. The column pole actually gives us what this is going to be, what we're going to have as our number here. 0, 1, 2, 3, 4, 5, 6, 7. We don't have anything actually add in until we get to the first row, or the first row. So if the 0th row is not 0, we've already got the value in y. So we can increase move the cursor to the next location and move to our character adjustment routine, which we'll go over later. Let's make sure that we actually need to process anything else. We don't, so we can go ahead and finish up the column. If we don't, we can finish up the column. Otherwise, we're going to need to continue our processing. All right, so what we're doing here is we're grabbing the row value from the previous character. Now, this becomes important because if we're working down a row, what we've done so far is like this is 0th row, that's fine. So let's say that we have a release here and here. Okay, we have a release on this row, so we need to go ahead and check that. Now, it's 1, but at the same time, the previous character that we dealt with had a row number of 0. We want to grab that 0 in order to be able to adjust it. Same here, we want to be able to grab that 1 in order to be able to adjust it. However, these are all, those numbers are all multiplied by a factor of 8. And with them being multiplied by a factor of 8, if we simply AND the previous value with the hex F8 here, then we'll wind up with the previous row value, and we can deal with the previous row value easily enough. Now here's where some of that magic takes place, because whether or not we've already advanced our current position, remember this LEA Y1, Y does that, and if we've got a bit that we're dealing with, then we're going to grab that value from there. And so now all we do is we add 8 to the value at the cursor position, and that brings us to the next row. And by the time everything's said and done, this row loop has running the row loop has gone through and done everything it needs to do. It'll have gone through every single key release in that row, and we'll have put those values onto the screen. Or at least put them onto the screen. Yes, it will have put those values directly onto the screen. So at this point, we need to deal with finishing the pole loop up, and there's some cleanup that we're going to need to do. So we need to make sure and restore what we didn't have before. Where we pushed it at the top of the loop, we need to restore it at the bottom of the loop. And we're done with processing that particular pole value, so we're going to save that out into the pole buffer so we can use that for the next time we go through and pull the entire keyboard. Okay, and of course move on to the next column. There's something that I forgot. There are a couple of things that happened at the top of the column that need to be taken care of. So like we did a complement A at the top of the column, and then if we go to the next, if we're going on to the next column, then we need to clean that up as well. We'll look at this code later. And then we need to update the new cursor position. And then once we're finished, at the end of the poll, we get the poll value back. We store that in the poll buffer, and we move on to the next column, just like I was talking about before. All right, but here's the trick, though. Once that 0 hits the carry flag, we're done with the poll loop. All right. And that's going to, and if we're done with all this, we're going to go back to our main loop. Let's look at the pieces that we haven't put in here yet. Okay, so what I'm going to look for is a BSR. All right, we haven't processed the inner, clear, or break. We haven't adjusted our characters. We haven't done our scroll check. And we haven't done our show cursor. So let's go ahead and get some of these into place. The first thing I'm going to look at is our scroll check. Now, the scroll check is actually relatively simple when you stop and look at it. And I'll pull up an extra window here. All we have to do is we need to check whether or not the cursor is at the bottom of the screen. And if the cursor is at the bottom of the screen and we hit enter, then we obviously scroll one up. By the same token, if we're overflowing, okay, we should overflow under those circumstances as well. And there's another trick to this. Now, I can sensibly backspace all the way through this, he says as he rapid fires the, well, I mean, it could be the back arrow key too, but you know. And it goes ahead and comes all the way back to the top of the list. But as soon as I hit the beginning of the line that I started on, it doesn't go any further back. So that's going to be important when we look at our dealing with the backspace key and things of that nature, because that backspace key should not backspace over the beginning of the line that we're working on. All right, so the first thing I'm going to do though is I'm going to look at processing the enter key. Okay, processing the enter, the clear, or the break. Okay, these are kind of important. So, all right, so when we get called here, A is going to contain, as we see over here, we've already complemented, or we're made a positive sense of the A value, which is the row value, or I'm sorry, which is the column value. So we have an easy way to determine, a little bit easier way to determine or think about where we are in, whether or not we're working with an enter, a clear, or a break. There are only three bits that would be set in order for it to be an enter, clear, or a break. So, real easy. If the 0th bit is set, no, we're going to check for the clear. So I'm not even worried about parsing or anything like that. All I want to do is deal with what the enter key does on the text entry side of things. So we're going to need this accumulator. We need to clear that cursor out, because there's going to be something later where we actually display the cursor. And ending this with an E-aught. What we're doing here, keep in mind that there are hex 20 characters in a given screen line. So that means you're going to be counting up by hex 20 every time, which means that hex 19 needs to be masked off, or I'm sorry, hex 1F needs to be masked off and basically dropped in order for us to find the left-hand margin position. So that's going to be E is the complement of 1 and 0 is the complement of F. So that's going to be an AND B with E0 so that we save the line location. So next we got to look at the clear key, and the clear key would have bit 2 set, so that's going to be, I'm sorry, bit 1 set. So that's going to be a hex 02. Okay, so I'm going to put in the break here real quick. Okay, and now let's deal with the clear. So this is actually a relatively simple thing. I mean, we've done the code before. And all we have to do is, and I'm doing this in the current cursor position because the current cursor position is going to be reset to the top of the screen anyway. Let's fix this. Okay. And break doesn't do anything. All right, so this should handle the processing of the enter, the clear, and the break. So, what about scrolling? Well, I showed you before what we were dealing with the scrolling, okay? The first thing is dealing with the enter. The next thing is going to be dealing with the scrolling, because the enter key is more like one of the two things that's going to bring us to a need to scroll. Now, thankfully, we've done that check up here after we've done the comm, and we're going to check for the scroll after we've taken care of all of our character entry and whatnot. So, and this is a nice, easy comparison, because if Y, which contains our current cursor position, is set to 0600, or is at 0600 or beyond, then we want the cursor's going to be off the screen. And it's that simple, at least at first, because we're assuming that we don't need to scroll. So the next part is, what if we do need to scroll? Setting it to the second line is important. What we're basically going to be doing is we're going to be moving everything up one line. So 420, or hex 420 is the second line, and so we begin to move them up. Because of the nature of how this has been done, there might be information off the screen edge that's already been put in there, because we're doing the scroll check after we've handled all of the characters. So we might have something after an enter that needs to come up and be put into the screen. Okay, real simple. Just a simple memory copy, and it's unfortunate that the 6809 doesn't have that. I think the 6309 does, but I'm working with 6809s here. So still, it happens relatively quickly. And no, it's not the most efficient. Stack blasting would be more efficient, but I didn't want to deal with that kind of potential insanity, especially where everything's kind of like a negative sense when it comes to stack blasting. We're cleaning up, and we are going to make sure to move the cursor position up one line. Now, the cursor position was actually below the screen by not more than one line. So bringing this up brings it to the bottom line of the screen. That means within a few characters, we're going to have to scroll again, but that's okay. All right, and that should take care of our scrolling. Now, again, we were demonstrating earlier that we had the problem of the back arrow. So now, in this case, what we've got in register A is, where's that called? Oh, no. Okay, never mind. Okay, so we're not doing that yet. All right, so we've got our enter key. We've got our scroll check. All right, great. So, but now what we need to do is figure out what's actually being shown on the screen, because we can go ahead and put just the raw values here onto the screen, but those raw values, those raw matrix values, aren't actually going to give us what we want to get. So again, if we look at this, we've got zero, let's see, yep, we've got 0 through F give us no problems. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And that goes all the way on to 18, 19, 1A, 1B. That goes all the way up to 1B. So that's going to be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm sorry, all the way up to 1A. 18, 19, 1A. So now, but the arrow keys, which actually tend to do something, if we just put that 1B, 1C, 1D, 1E in there, it's not going to be right. And 1F, the space, is supposed to give us, a blank character, but 1F is actually the back arrow. So obviously, some translation needs to be done. And then we run into this problem. As soon as we hit 20, hex 20, well, 20s is 0, and then a 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, okay, that's great if we add hex 10 to that, so that's actually 30, 31, 32, 33, 34, etc., etc. Okay, so now if we're looking at a 30, the 30 is actually the intercalary break, but we've already masked that off for processing, so we should never see those on the screen. And we've got the following complication as well. We've got shifted information that's going to need to be put in here as far as these are concerned. We've got to adjust whether we're showing the 0 or whether we're showing the 1 or the exclamation point. We've got to make these adjustments from the raw information. So instead of like sitting here and going, oh, woe is me, let's go ahead and get these character adjustments done. All right, so the character value that we want to work with, Y has already been incremented. The cursor position is already beyond where we want to work. So I'm going to be grabbing 1 less than, the location 1 less than. So now in this particular case, what we're going to be looking at is a specific set of characters, going to be 28, 29, 20A, 20B, 20C, C, D, E, and F will have what's printed as their unshifted values equal to the value that you're going to find when they're processed. So we don't have to deal with shifting nonsense with these guys. Well, we don't have to deal with initial shifting nonsense with these guys. So, okay, so we can move on if we don't have to worry about that. But if it's lower than that, we're not going to worry about these. If they are, we still have to deal with the shifted possibilities. So, and in this particular case, shifting these right here requires that we add the value of hex 10 to them, which brings them over here, so we get the items that are so that we get the shifted characters right there. So comma is unshifted, less than is shifted. All right, so looking back at all this, that's done. Now, by the same token, if we're dealing with the other set, not including 0, with these, the shifting sense is reversed. So, now another special case is the 0 key. The 0 key always has to have that adjustment put in there. Now we're on to the space bar, because keep in mind, we're moving backwards along this. The next one to come up is the space bar. The next step that we need to work with are the arrow keys, and we'll deal with those in their own place. And finally, we need to see if this is an alpha character. And we're going to give an inversion of video for alpha characters that are shifted. And so we're done. And in the value A, we have our modified value to put onto the screen, so that it correctly represents what we're actually receiving as far as keyboard input and what that's supposed to be. All right. So we've adjusted our characters. But now we've still got this little thing about what to do with the arrows. Well, okay, so we've got 4 arrow keys, and let's see what we're doing with them. There is not a caret. That is on any of these. So traditionally, what's been used in the Coco is the up arrow has been used to print the caret. The down arrow has, at least in basic, doesn't do anything that I'm aware of. And the left arrow is used as your destructive backspace. Right arrow from what from what I've seen in BASIC, it doesn't really do much of anything. But we need to process, at the very least, the up arrow and the right arrow. I'm sorry, and the left arrow. So let's get those processed. And when we come here, we're going to be coming here out of the character adjustment because until we're testing a shift, where to go, do arrow. Okay, yeah. So we're coming here out of that. So we're already going to have the key's value, scan code, if you will, already in the register. So we don't have to worry about making anything new there. We can just go right into it. All right, so for the up arrow, we can just simply do a quick change in what it does. Remember, we wanted to show the up arrow character, and that is hex 1E right there. All right, so we're done with that. What are we looking at next? How about the down arrow or the right arrow? Well, let's see what we've got. Okay. Let's look at something real quick. Yeah, the down arrow and the right arrow are not sequential, so we got to do it this way. Okay, we're going to continue. And then if it is the right arrow or if it's the down arrow, we're not really doing anything with those right now, so I'm going to go ahead and just have it return. Oh, there's something that I forgot. All right, I can't just have it return because here's the trick. That has already pushed the cursor location, forward 1 unit. So since it's done that, we have to restore the old cursor location and clear out the cursor location that's there. So before we return, and that'll make sure that we've got everything properly stored away. There we go. That's better. That would have annoyed me. All right. So next, the left arrow. Now, process of elimination says that we should only have, like, if it's none of these, then it should only be this, based upon what we dealt with up here. But I don't trust that just yet. We can save some bytes once we've verified that it's correct, but I just don't trust it just yet. Now, here's where it comes in. We need to make sure that we're not going beyond, like, that we're not going back over one of the previous line entries. So when we hit enter, we want it to stop at the margin. We've dealt with checking for an enter clear break, and we've processed all that. We have processed our scroll check to see if we need to scroll anything. We've processed adjusting the characters so that what we get as far as a scan code is translated to something that makes sense on the screen. We've handled our arrow movements. Now, the one thing that we have not yet done is we have not yet set up a cursor. So let's have a little fun with setting up the cursor. All right, so I want to see what we have as far as graphics characters. That's what I wanted to do. Okay, I keep forgetting that I did that. Okay. We're going to hit the, let's see, we're going to do that before the start and after the org. So we can do this here. And we'll just kind of rotate through those bytes. And we got that shape going on. And I've already put in here where we're going to actually show the cursor. Well, BSR show cursor, that's great. So now all I need to do is get that defined. How are we going to use this cursor shape? All right, so first thing we do, let's go ahead and grab our current cursor location. Okay, something that I want to do. I want to make sure that this is actually visible and makes sense. So we're going to put a little bit of a delay in prior to each one. Okay, current cursor to a C, okay, is shift is at C, so that's going to be +2 is shift. And let me add this one. Alrighty. Good, good. All right, so we're going to use the cursor delay, we're going to use a variable for the cursor delay. And we're going to do this, we're going to update the cursor, let's say once every 4 frames. So that's going to be, so if that comes up as a 0, then we actually want to process something. This is going to look a little bit weird, but what I'm going to do is I'm going to skip over an RTS. Okay, great. So now we're going to increment, now we're going to change out what we're doing for the cursor. And remember, the cursor position has the cursor character in it because this is where the cursor is sitting. This is the input position, not the last character. If it's not blank, then we're not at the start of a cycle. Remember that 0 is the last shape. Now, if we are at the last shape, now all we need to do is go back to the beginning of the list and set our new color. Now, if we wrap around, which will happen if the carry is set, we need to go ahead and reset to the first color in the list, which is hex 80. What we've done here, the last shape just basically wraps everything around and resets to the beginning of the line. Otherwise, what we're going to need to do is deal with the lookup table. So all right, and that should be everything. So it looks like, I mean, it's a bit of a, it's a bit of a little minor monstrosity when we look at everything that's in here. And it's absolutely surprising how much we're having to deal with, because we have to deal with the scrolling, and we have to deal with the adjustment of the character values, and we have to deal with whether we're backspacing or forwarding or anything like that. It's a little bit much. Now, if I've done this correctly and I'm copying my own homework correctly, then this should assemble with not much more than a, hey, it's out of range. So let's see what happens when I assemble this. Okay, so it's gotten a syntax error at line 205. Let's see what I did wrong. Why is that simply saying syntax error? Saying at 209, and it's giving me blank information. So I'm guessing that I've got some blanks there that I didn't know I had before. Oh, there we go. That solves that problem. Symbol is shift not defined. All right, 109 and 222. All right, it's assembled fine. So now that it's assembled fine, all right, that's a good sign. I've got a cursor. And that's not a good sign. Something went terribly awry. All right. So let's go ahead and get this into debug mode.
So much later that the old narrator got tired of waiting and they had to hire a new one.
All right. I think that does it. All right, that fixed it. All right, beautiful. Let's see. So that's done, and so what we have now, yeah, and it even clears the screens. Nice. Okay, good. So this is all working. This is a very good thing. Awesome. So now it's working. We've got text entry. We don't have any way to save it. We're not doing anything with it, but we've got it. We've got the basic interaction with the keyboard going to the screen. And right now, that's all we need. The next part is going to be a little bit more convoluted because the next part, we need to take in the data that's being put into the computer and parse it. It was a little bit more annoying than I thought to go back over my old homework, and I thought like copying it would be fine, but no, I had to make some changes, and so some errors were made. But hey, at least it got working, and it got working the way that it needs to be working. And I especially had fun putting that a little swirly for the cursor. I thought that was kind of nifty. At any rate, thanks so much for stopping by. Be sure to like, share, and subscribe. Go ahead and leave a comment if you've got any questions, or let me know what it is you'd like to see. I'm thinking about the next hardware thing being an EEPROM programming thing, crack open the Coco and see if I actually need to socket some things. We'll have it all figured out by the time we reach the frontier, and that's a pretty normal thing right here at the break key. Because again, we're moving that bit. Okay, yeah. We're moving that bit. I'm going to make you stay on top, because you staying on top helps me demonstrate what I'm trying to do. And then I can move you off to another screen that's not on camera. And then once I've moved you to another screen that's not on camera, I can see the whole thing. Let's do it that way, because that makes entirely too much sense.